What's up, everybody? This is Tech G back with another video to help you successfully pass the CompTIA Security Plus certification exam. So let's get into it. In this video, we're going to deep dive into the critical activities associated with vulnerability management. Vulnerability management isn't just about finding weaknesses. It's about understanding, prioritizing, and addressing them in ways that align with organizational goals and risk tolerance. So let's break this down step by step, starting with how vulnerabilities are identified. The first step in vulnerability management is identification. This is where you ask what weaknesses exist in our systems, applications, or processes. So let's explore the various methods. The first one is vulnerability scanning. So think of this as an automated checkup for your systems. Vulnerability scanners like Nessus or Qualys, they assess systems for known vulnerabilities, checking configurations, missing patches, and outdated software versions. While efficient, scanners might also generate false positives, which we'll discuss shortly. Next, we have application security. So applications, they require their own set of checks, and here's how to approach them. The first way is called static analysis, and this examines source code before the application runs. Tools like static application security testing. This can detect potential vulnerabilities such as hard-coded credentials or insecure functions. Then we have what is called a dynamic analysis. So unlike static analysis, this tests an application in real time while it's running. Tools like dynamic application security testing simulates attacks to find runtime vulnerabilities like SQL injections. Then we have what is called package monitoring. This focuses on third-party libraries or packages, and tools like Dependabot, they can scan for outdated or vulnerable dependencies, helping ensure the software supply chain is secure. Next, we have what are called threat feeds. So threat intelligence feeds keep us informed about the latest vulnerabilities and attack trends, and they come in several forms. The first one is called OSINT, or open source intelligence. And this is freely available resources like MITRE ATT&CK or the National Vulnerability Database. Then we have proprietary and third-party feeds, and these are subscription-based services that offer in-depth curated threat data tailored to specific industries. We have information sharing organizations. So information sharing and analysis centers, they are great for collaboration within sectors like finance or healthcare. And then we have what is called dark web monitoring. So yes, even the dark web, this can reveal vulnerabilities if attackers are trading or discussing exploits related to your organization. And then next we have what is called penetration testing. And this is where ethical hackers simulate real-world attacks to find vulnerabilities before the bad actors do. In pen testing, this goes deeper than scans by exploiting weaknesses to understand their true impact. Also, we have what is called responsible disclosure programs. So bug bounty programs like HackerOne, they incentivize external researchers to report vulnerabilities. And these programs foster collaboration and transparency while addressing security gaps proactively. And then we have system process audits. So audits, they assess processes and systems for compliance and vulnerabilities. And regular audits, they ensure that security practices evolve with threats. All right, so moving on to analysis. So once vulnerabilities are identified, we need to analyze and prioritize them. And here's how we do it. So the first thing we need to do is confirm whether it is a false positive or a false negative. So false positives, this is basically where not all reported vulnerabilities are real. And false positives, they waste time. So verifying the results is essential. And then we have what is called a false negative. And these are basically more dangerous if the vulnerability is missed entirely. So ensuring robust detection methods, this can reduce these as well. And another way we analyze things is through prioritization. So we can't fix everything at once. So prioritization is key. And here are some of the tools and factors that help with the process. The first one is called the CVSS, or the Common Vulnerability Scoring System. And this provides a numerical score for each vulnerability based on its severity. Then we have what is called the CVE, or the Common Vulnerability Enumeration. This assigns unique identifiers to known vulnerabilities for easy tracking. Then we have the vulnerability classification. So categorizing vulnerabilities by type, such as critical, high, medium, or low. This helps allocate resources efficiently. And we have what is called the exposure factor. And basically this asks the question about how much damage could the vulnerability cause if exploited. Then we have environmental variables. So consider the unique context of your organization, such as network architecture and user behavior. Then we have industry and organizational impact. So a vulnerability in a healthcare system may have have life-threatening implications compared to one in an entertainment application. And then we have risk tolerance. So organizations, they must decide how much risk they're willing to accept based on their goals and resources. All right, now that we've identified and analyzed vulnerabilities, it's time to respond and remediate. So the first thing we're going to do is patching. So this is the most direct method. So you want to apply software updates or patches to fix vulnerabilities, and you want to prioritize patches for critical vulnerabilities. Then we have insurance. So cyber insurance, this can mitigate financial risk associated with breaches caused by unpatched vulnerabilities. Next thing we have is called segmentation. So network segmentation, this limits an attacker's ability to move laterally within the system, which reduces potential damage. Then we have compensating controls. So when immediate fixes aren't feasible, you want to use compensation controls like firewalls or intrusion detection systems to mitigate risk temporarily. Then we have expectations and exemptions. So sometimes vulnerabilities cannot be addressed due to business constraints. In these cases, you want to document exceptions and implement monitoring. All right, so moving on to validation of remediation. So the job isn't done after remediation. Validation, this ensures that the fixes were successful. So the first validation is called rescanning. So you want to run vulnerability scans again to confirm that the issue is resolved. You want to conduct audits. So conduct formal audits to review the remediation process and verify compliance. Then you want to verify this stuff again. So this stuff often involves testing by internal teams or third-party experts to ensure that vulnerabilities are fully addressed. And then finally, reporting. This ties everything together. So comprehensive reports should include the following. So what vulnerabilities were found, their severity and their potential impact, the steps that were taken to remediate them, validation results to confirm resolutions, metrics to track progress over time, like reduced vulnerabilities or shorter remediation cycles, and insights to improve future vulnerability management processes. So in conclusion, that's vulnerability management in a nutshell. It is a continuous process that requires diligence, collaboration, and adaptability. By mastering these activities, you're not just securing systems, but you're protecting the very backbone of your organization. Now, with all of that being said, let's do some of this check on learning. So the first question is, which of the following is an example of an identification method used in vulnerability management? Is it rescanning, dynamic analysis, compensating controls, or industry organizational impact? And the correct answer is it is dynamic analysis. So dynamic analysis, this is a method used to identify vulnerabilities in an application by testing its behavior during runtime. This differs from static analysis, which examines code without executing it. And other identification methods include vulnerability scans, threat feeds, and penetration testing. Next question. When prioritizing vulnerabilities, which metric helps determine the severity of a vulnerability by assigning a numerical score? Is it the common vulnerability enumeration? Is it the common vulnerability scoring system? Is it the responsible disclosure program? Or is it a false positive? And the correct answer is it is the common vulnerability scoring system. So the CVSS, this assigns a numerical score to vulnerabilities, helping organizations prioritize remediation efforts. It considers factors like exploitability, impact, and environmental variables. CVE, on the other hand, this provides unique identifiers for known vulnerabilities, but does not assign scores. And our final question, which of the following best describes the purpose of compensating controls in vulnerability management? Is it to verify that remediation efforts were successful? Is it to address vulnerabilities in cases where remediation is not possible? Is it to identify vulnerabilities in an application during runtime? Or is it to provide a numerical score to prioritize vulnerabilities? And the correct answer is it is to address vulnerabilities in cases where remediation is not possible. So compensating controls are alternative measures implemented when direct remediation, such as patching, is not feasible. These controls aim to reduce risk to an acceptable level until the vulnerability can be fully addressed. And examples of this include segmentation and additional monitoring.